Okay guys, let me know if you can hear me. I need to get a few things together, like my mouse and my eyes. Let's see, I think I can, good. Okay, can people hear me? First question. Let me know. Can you hear me? It's funny, I didn't get arrested, but I have to tell you, I had to walk past a police car, with its lights on, and 2 policemen in it. And it isn't even subtle, because I have a retro-reflective jacket, which means it's probably the brightest thing in the entire street. You haven't got a stream yet. Join the technicians. Okay. Hopefully. All good now. Excellent. Okay, so I'm just going to get a few things in order here, and I will be with you. So firstly, I'll get rid of a few extraneous apps so I don't break my computer. Okay. You see it refresh. Right on. Okay, excellent. So I'll just wait until people are in the room. Maybe there was a little confusion because it went from one place to another. I don't know. Okay, let's see what happens if I do that there. So I want to thank those people that have been taking a look at the presentations and doing some thinking about it and coming back with some feedback. That's really very helpful. I want to say something about what happened last year. It would have seemed, got the COVID very early on. And I have to say thank you to one of the community, because they sent me half of their prescription from Germany of a drug that wasn't allowed to be popular in many countries. Anyway, that sorted me out. I did get my SpO2 levels down to 94%. But I can honestly tell you, I think, other than obviously family, the thing that I felt most, because this was in March, so it was very early on before most of the Western world had really got a serious dose of it, and I felt really like I'd let the community down because I felt that I had not got anywhere near out the information that I wanted to. And I'd worked as hard as I possibly could, but I thought if I was going to die, I would be absolutely gutted. It would make a complete farce of the last 8.5 years of volunteering and all the work I did before that to be in a position to understand when the opportunity was given to me. And one thing that I really wanted to get out was this idea of the apparent magnetic monopoles that is taking place in Lena, and essentially all kinds of exotic energy systems. And so I ploughed on ahead with that in the first half of last year and got that out. And anyway, it's funny because even when I was at Aarhus University there, I was speaking to the head of the chemistry department and other people there. I said at some point in the future, there will be entire universities dedicating themselves with different departments to studying the various aspects of what this technology makes possible. At its absolute core, it's very, very simple, and I will share some of the things that I published, just skim over them, over the last year or two that are relevant to this geo-polymer molding technology. And it's interesting when you realize the way this can manipulate matter, it becomes almost obvious how many different areas of science it can impact. And so, you know, there are clearly people that knew about this technology, both in the recent past and in the ancient past, even on this planet. And it is disturbing to me that we've been sold a lot of nonsense. But I can only put it down to really genuinely don't understand what it could do other than blow things up. I'm going to say a bad word then, but blow stuff up. And that's the sad part about it, because that is the easiest thing you can do with it. And so anyway, I'm going to switch to the original article, which I fleshed out on the geopolymer subject, and just run over some of the things that I put in there if you haven't read it. I think you will see that there are experiments. So I'm gonna look at the questions. Do you take down that video? I'll have to look at that. The HOPE project. This is an open project. All I ask is that people credit the people involved. I do my absolute level best to, if I can see that some technology has already been discovered, but it was given a different name prior to someone claiming it now, and it's been published, when I find that out and recognize that it is exactly the same thing, I do my level best to ensure that they get the credit for being the first to put it into the public domain. I think, you know, I'm as I said, from 2017, this is a realization for me, because it was so obvious that this had already been discovered. It was a huge disappointment for me to realize that, but also there were people that didn't want other people to discover it, and people have short lives and they have to do the things that they have to do in their lives to, you know, get from the beginning to the end, and that makes it very hard for them to see the wood for the trees, as I call it. So if the HOPE project wants to put things out there, please just give credit to the project, the MFMP, because the work that I've been privileged to be a part of with my colleagues was only made possible by donations from literally thousands of people, and they would be you need to do them credit, because they channeled their intention through the project, and so the project should be given credit, and you know, just give credit where credit's due. That's what I ask for. So you've got a lot of things in there. You look a little bit like a bot the way you post, but anyway. So David, the helium comes from the decay of uranium, etc. That is deep in the earth. Yes, you can get helium, and you can even get tritium. Tritium actually probably could be from fusion, but anyway, you can get tritium coming out of volcanoes as well. And technically you wouldn't expect that, but you do. And anyway, the helium, if you look at how this technology works, one of the biggest products that it can produce, whether it's coming from light elements or heavy elements, is helium. And the reason is that it packs material, as I called it for a number of years now, into a very small box. It's not a black hole. It does have a finite dimension, and that dimension, in my understanding, is that minimally of an alpha particle, 2 neutrons, 2 protons. So, and because that's a boson, if you can pack it in there in a coherent state, you can literally put Googleplexes of alpha particles on top of the same space-time. Of course, in the magnetic monopole research that I've put out there, and my own understanding is that if you push this too far, it'll actually rip the nucleons apart, and it converts it into a range of leptons, both charged and uncharged, and photons. So ultimately, anyway, I have a specific name for this, and probably when I've gone through a number of things, probably around about September, I will reveal what I call this since 2017, but I want people to guess. It'll become increasingly obvious. Anyway, so helium can come out of it. And in fact, in S.V. Adamenko's work, and it's in the monopole clutch video I presented to the Russians at the Russian conference this year. S.V. Adamenko in the early 2000s used a 1 to 300 joule, 1/10 the speed of light, relativistic, high DIDT discharge through a dielectric barrier. And he discharged that into a small sample. But he found these things around his accretion plate, and they had structures in them that were able to absorb matter and emit light, sort of like Hawking radiation. But he also observed these structures exploding, and they exploded with a vast number of alpha particles. So Takaaki Matsumoto calls this nuclear regeneration. So you can go up and down the periodic table. But the things it tends to produce, if you're just using it not too intensely, is the things that make life. If you do it very intensely, as S.V. Adamenko did, you can or Leclerc with his cavitators, you can create all of the transuranics and very heavy elements like americium-241 and things like that. But Adamenko actually created things with like sort of 455 AMU. These are nuclei that don't exist in our near universe, and was able to create that repeatedly in the lab. And that actual reactor went to America, and it then is now, I think it's at Brookhaven National Laboratory now, and they're trying to make it into a fusion system. But I think it was a nice proof of concept. I don't necessarily think it's the way it's to go. I think controlled, coherent balls of fire, or whatever you want to call them. And I actually came up with a generalized nuclear remediation reactor and energy producing fusion reactor concept. And I'm probably going to maybe walk through that next week. But it's essentially using something that I saw at the Russian conference in 2018. If you want to get ahead of me, go and look at the video presentations from Sochi from 2018 from Anatoly Klimov. See if you can guess where I'm going with that. But it's essentially would be looking to transmute matter. Okay, casting some fresh TT Brown gravitator parts right now. Very good, join the technicians. Very good. Okay. Okay, so I'm just running through this as quick as I can. Tim Ventura and Ron Keeter have been chatting about getting greenier on APEC. Well, maybe I will, and maybe I'll reveal some of the other insights that I had in 2017 and cross-correlate that with some presentation slide that I made in Consigliani di Asti in Italy on, I think, June the 6th, 2017, I think it was. And then the cross-correlation with that, between that and something that I observed on this Hutchison sample, and what that means in relation to ancient technology. I was absolutely blown away beyond all measure when I saw this, and really I think the cat is going to be, it is completely out of the bag. As I said, I'm going to give you another keys to the kingdom, as it were, today, and if you really look into it, you'll see that that's what it is, and we'll get this out of the way. Okay. Right. Yes, David, yes, it needs replication. And there's several experiments that I'll talk about today that could be replicated at various different labs. Hi, Louis. Shout out to the ancients. Yes, thank you. If they hadn't let you will know that it's not approximate what was set in stone. I use this phrase set in stone, and it's quite appropriate about the subject we're talking about today. But they literally set in stone and to comical levels of preciseness about how this technology works. So it's absolutely certain that they knew what they were doing, and that they knew that whatever cataclysm happened or whatever battle happened that resulted in them passing, it might have been intention or just luck, but really the only way to preserve this technology for posterity is to carve it onto stone in very simple forms and bury it about 70 to 100 meters underground. And I will go into why that's relevant at some point. Okay. I did not create the Lion device. There is a researcher in the UK who calls himself Lion. For whatever reason, he wants to remain discreet, and we do honor those requests. He just sent the thing and said, I think this produced excess heat. I think I'm doing everything right. Would you have a look at it? And around that time, I'd seen the strange radiation tracks coming from the echo fuel that I'd got from Suhas Ralkar in India. And so I'd learnt from the phrase that there's two phrases. In January 2015, Piantelli said, don't tell nature what it is, let nature show you. He told us that when we were with him as part of Project Fedora. And then the second was when I did the transcript of the Hutchison and Ken Shoulders interview with Nancy Lazarian, John's wife. The phrase that stuck out to me was, it's so difficult to not find stuff, and it's so difficult not to see stuff, and you won't even know what you didn't find. Something along those lines. But it's essentially, if you don't bother looking, you're not going to find anything. So those two things stuck in my head, and I thought I'd really change my whole approach to LENR, because people are always going to dismiss the excess heat. You're going to have challenges. I mean, it had almost been set up that what you had to prove were the things that were easiest to criticize. But in the Lion reactor, it's shown these magnetohydrodynamic structures, these transmutations, these flux loop structures, these structures that are physical embodiments of exactly what was observed by Winston Bostick from 1949 through to the early 70s, when he was working 3 national labs, I think, in the US to try and convert the fusion technology, the H-bomb into domestic fusion technology. And this was the thing that was the go-to place for Ken Shoulders when he was trying to explain John Hutchison's work when he was brought in to do that work in 1981. So the bloodline was there, and so I said, and I thought I just have to look. And when I saw those things, which were exactly what was being observed, but in plasma photo pictures by Winston Bostick and so forth, it felt that I was on the right path to understanding this. And then having published all of those images in macrophotography, in microscopy, in scanning electron microscopy, and looking at the elemental distributions, and them being in some sort of morphic structure similar to the actual features as you would expect them to be formed by these exotic vacuum objects. It was a shock on August the 22nd last year to find that this Russian Solin had been researching and had submitted a patent in late 1992, and he had drawn into his patent exactly the same structures that I had been sharing for a number of years. So it was kind of like, oh my God. And he went on to say that this is producing magnetic charges, and that they get to a strength where they can unify the forces, which is basically what there was at the so-called beginning of the universe, and cause nucleon decay. And so this really is, it's basically all there is. When these things are, as I said, it's something that Ken Shoulder said, it is the clutch. It's the clutch that allows you to engineer reality and so forth. So, okay, so I'm about ready to go. How maybe the nubs found on megaliths due to some vacuum. Yeah, no, that's kind of what I said actually in the last presentation. I said you might put something on those nubs and suck to suck the thing into the mold, as it were, because I've actually done vacuum forming. I have the original Stormtrooper double faceplate, and I had a friend that did scenery for films, and I saw these vacuum forming tables. In fact, I have a video of Andrew Ainsworth in his Shepperton studios vacuum forming the Stormtrooper mold, so I understand these kind of processes. I did manufacturing engineering and studying, so I'll try and do that, Jay. I'm not entirely sure what you're referring to, so let's do that afterwards. So NASA, I'm going to address the NASA work here, because I believe that it comes from the Pam Mosier-Boss and Larry Forsley work at SPAWA. And Ken Shoulders in that 2010 interview criticised them absolutely, because he said that they don't even know, they haven't got neutrons. They think they've got neutrons, but they haven't got neutrons, and they don't even know how to look for neutrons. Now, I love both of them. I think they're great. And it's not to say that the technological embodiment doesn't work and it doesn't produce cold fusion. But I actually disagree with how it's occurring. And I've said that to Larry. I haven't had a chance to speak to Pam. Unfortunately, it's got a lot of press, but if you look at the papers in Physical Review C, they are not, they have CR39, which we know exotic vacuum objects interacts with. I've had tracks in multiple forms of plastic, and CR39 is the type of plastic you have in plastic eye lenses. It's quite scratch resistant, but exotic vacuum objects produce tracks in CR39, so you can discount that. The rest of them are scintillators, and scintillators are, if you look at, I did a presentation called "Why Did We Not Get This in 1995?" The reason was that was a presentation at ICCF, I think it was 6, something like that, an early ICCF, and it was by Takaaki Matsumoto, and he said that if you have any form of scintillator, the electronics gets fooled by the kind of radiation that comes out from these reactors. And we actually observed exactly that, and exactly the kind of disturbance of signal that you get in January, February, something like that, 2015 in glow stick 5.2. So we've observed this, and it's not real radiation in the sense that you would think it is. And in fact, there is a presentation by Frank Gordon that's going to be presented this weekend about more discovery about this radiation. We call it strange radiation. In fact, it's various different quantas, and it's the monopole, as far as I can understand it, the monopole type structure. If you look at it on an X-ray, it ends up having this birdie shape, but it can be like a bent and a straight bit, and that's what you're looking at. Is because these things like to go 50% into a material and get stuck. You're looking at a section through it, so it's actually more like a mushroom. And in fact, I called it a mushroom. I took a picture of a mushroom when I was doing my presentations, and then I came across this paper from 2012 or 13 by another Russian called Provchikev, and I'll talk about that in a few minutes. But he actually called it kind of like a mushroom structure. So anyway, this structure is like a pseudo monopole. It's like a kind of a primer field, but but that's just an extension of the type of Boyd-Bushman magnetic beam patent that's awarded to Lockheed Martin. But anyway. Okay, so I'm going to do look at just a couple of points from that came out of the previous presentation, and I'm going to try and switch to that now. Let me see if I can. I'm still not getting very good at this, am I? Okay, desktop and that window. Okay, all right. This is not so bad, is it? Okay, there we go. All right, let's see if this works. Can everyone see that? There we go. Okay, all right. So this is where we were, and I went through, that's the presentation. These are the abundance in the Earth's crust. That's the theory of Peruvian walls. Now, there's melting, and then there's non-thermal melting, and it's non-thermal melting that I'm focused on in these presentations. And so I fleshed out the commentary that I made very scrappily in the video the other day, and I put the details in here, the temperatures and so forth. And I said that effectively I believed that the copper, which we had proved contained exotic vacuum objects and in a range of different ways. And we know that they produce X-rays because we exposed, or rather Lion exposed X-ray film. We know that it had these exotic vacuum objects in there. And then I argued the point that copper is diamagnetic and highly conductive, so it would be a reflector, but it could, if you got to a certain level, they could bind onto it. But then the oxide of copper is like, what is it? It's a semiconductor and so forth. And in fact, the I think the second oxide, the Cu2O, is I think it's actually like a not magnetic, not paramagnetic, diamagnetic. So essentially, it goes from being wanting to prevent the EVO coming in. As it oxides more, it then sucks it into itself, and so this would actually fit what we observe. And so it's not rich, and then suddenly it becomes rich in exotic vacuum objects, and then they can start churning through the rest of the material. Now the oxide, the Cu2O, is supposedly melting at 1,232 degrees C. CuO, rather, the higher oxidation state is 1,326 degrees C. So the fact that it can actually melt when the reactor is only supposedly at 1,084 degrees C is a little bit weird to think about. But anyway, so I went through that. I won't go in that. What I wanted to talk about actually is I'll go right to the bottom. So there was this Australian guy. I probably can't get his name right. He's called Mescal or something. Maybe that's from mescaline, I don't know. But anyway, Mescal. And he did an experiment inspired by my commentary that if I was to try and make this geopolymer, and I had sand, and I had silicon dioxide grains, and I had aluminium oxide smashed up, and so I had a powder of aluminium oxide, and I had sand, and I wanted to put maybe some potassium oxide, I would add magnetite, and the magnetite would act as something that the exotic vacuum objects could cluster on, and then it would act as a kind of like little machines that would churn everything together, and then it would end up being a solid block. But what you'd want to do is to create the coherent matter at a non-thermal temperature, ideally, and we're going to discuss that aspect a little bit more. What else? So there was that, and then I, after my presentation, I thought, you know, what has andesite actually got into it? I would, you know, it's probably got magnetite in it. So let's have a look, and I found that andesite actually has magnetite in it, and this isn't from Bolivia, but it's I think it's another part of the Ring of Fire, so it is not unreasonable to be a similar type material. But if you look here, these little white islands that you see over here in this 100 micron image, these are different samples. These are magnetite bubbles, as they call them. And in fact, down here, you can see in this sample, the magnetite bubbles are quite evenly spaced around, almost like they've self-organized themselves in the material. If you actually go and look at the paper, there's a range of the magnet. Sorry, just to answer Join the Technicians, I've already done a presentation about the magnetic beam. I will write what that is at some point, but I've already done it and how I came to create something similar. But anyway, yeah. So my proposal then was, as I put down here, is that if you can imagine, I'm going to get some little little magnet squares here. So I've got these little magnet squares here. And if you can imagine, this is my bubble of magnetite, and I had a coherent matter wave beam that I could go onto here, I would imagine that the coherent matter would coalesce, because these exotic vacuum objects, they are always magnetic, even if they're not charged. And so they would coalesce around this and form a bubble around it. And if I then made that big enough, if you can imagine, each of these little white spots that you see here has a sphere around it to a degree. And then you energize that to go. And what I'm saying is that a coherent matter wave beam that is in the dark mode, i.e., it's not white. It's like a well, the Russians call them string vortex solitons. They're condensed clusters of cold neutrinos. But anyway, you can then energize those, and then they will go into the white phase, and you only need to energize them to a certain degree in order that they start to cause slippage of the material, i.e. they're kind of semi-liquidizing it. And you will see, in my view, that kind of effect occurring in samples like this aluminium from John Hutchison, where it goes into like a kind of jelly-like state. Now, if you pushed it too hard, you might be in a situation where the thing like blew up. Now, so that was the concept that I wanted to put across there. And in fact, I said what you could do is you could actually go to the quarry and either and charge these things up and energize them so much that it literally turned the entire magnetite, sorry, the entire andesite into dust. And then you would bag the dust up, carry it in a little, bag to your construction site, push it into your wooden mold, and then re-energize it to a level where it goes into this like jelly-like like he's got here. If I show you here, he's showing that by putting high frequency, high voltage through this magnetite, he's able to manipulate it, and it'll join together. Now, this is obviously also got a thermal component to it, but if you were doing this on bulk and you had the exotic vacuum objects so that they're not dissipating heat away and they're relying on coherence in influencing electron bonds rather than melting them to make them just fluid, then I believe that's how you could mold it. You read about coherent matter beams used on the surface of flying craft from Lockheed. Well, there you go. I rest my case. It is coherent matter. They basically cover the whole thing with a ball lightning. And I mean, I don't know if I have not seen that pattern. So if you could post that pattern, Terran Earthling, it'd be great to have a look at that pattern and see how significant that is. But this is how it works. And I mean, the cat's out of the bag now, and I'm going to give you another couple of keys to the kingdom now, and make the correlations that I think you need to have made to be able to see that it is what it is. Okay, so I talked about the fact that when EVOs are formed at room temperature, as per Hutchison Effect, TL Carr, and I've given a link to Ralph Ring's account there, and the Tom Bearden's Fer de Lance, his account, and Dr. George Eagley's natural ball lightning studies. It would allow this manipulation of what the Russians called in 1992 cold metal molding. And we know that this exotic vacuum objects, even cold, will bind to iron and nickel. And I've given 2 links there. So the link to the iron study is here by Rudskiev. I've discussed that, and the nickel one. And so when it's on that magnetic thing and it's not hot, it's not going to take that iron oxide, that Fe2O3 or 4, whatever it is, the magnetite, Fe3O4, or 4. God, I should know that by now. Fe3O4. It shouldn't take that beyond its Curie point. You will be able to build up the EVOs on there, and then they will enable you to manipulate your matter. So thank you. I'm very keen to look at that, Terran Earthling. It's interesting, but for me, it's kind of like I had this realization in 2017, and it was like every one of these things is now possible. every one of them. And it doesn't take a lot of intelligence to realize that that is the truth. And so what I wanted to do is over the last couple of years is be able to show the physical evidence. And I believed I'd done that by the beginning of last year. And then I could walk through the monopole stuff and how that influenced matter and could make matter and destroy matter and so forth. And then I was just amazed that when I found in August the 22nd the Solin patent, which basically argued exactly the same things, but from work that was done prior to 1992, and then the Lockheed Martin patent, which I observed in September last year. So this is how it works. Okay, so. If I do present on APEC, that would be great. But I think I did say about at the beginning of 2017. By the time this journey is finished, I think pretty much everyone who's got money is going to hate me. Really, honestly, everyone. And this comes into consciousness and religion and all kinds of weird stuff. So anyway, I'm going to go to the new presentation here on the blog here, because there's some things that I want to talk through. So the first one I want to talk through is the Hutchison effect. So I'm just going to read what I wrote here earlier this afternoon. Last year, after an extensive study of John Hutchison samples, I concluded that some form of magnetic monopoles were the cause of metal failures in Hutchison samples. When I recounted that understanding to John Hutchison, he told me that George Hathaway, a current consultant on the Sapphire project, had concluded the similar thing in the 1980s. And so I've talked about this. You can go and have a look at that video in your own time. And then this is my Russian presentation from 30th September last year. And anyway, having widely discussed the importance of some form of magnetic monopoles in the first 2 quarters of 2020, on the late August 2020, I came across the 1997 awarded 1992 application Solon patent for quantum coherent reactor, where he discusses it produces magnetic charges. And I've got that actually linked to the right place here. And so he used an electron beam furnace. So this is essentially a kind of like a linear accelerator. You have maybe a thermionic emission of electrons, and then you have an accelerating electric field. And then he shot that into a low vapor pressure metal, so something like zirconium or molybdenum or tungsten. And the reason you do that is because when it goes in, the electron beam will actually melt the metal, but it will only be able to melt it out to a certain point, and you'll get what's called electron bunching. And it's described well in the patent. And the electron bunching leads to coherence, and the coherence then leads to a resonant phenomena where you have the boundary of the solid metal against the liquid metal. And this allows a resonance to build up there, and it's self-regulating, because if it gets hotter, it gets a bit bigger and it starts to cool the process down. If it gets cooler, then it goes down, and so it's self-regulating. And this causes coherent matter and leads to the formation of the exotic vacuum objects. And at that time, he didn't have the understanding that if you go over 1,000 degrees, you have the kinetic impact required to start producing both axions, which some believe are condensed cold neutrinos clusters, and also cold neutrinos. And these cold neutrinos are not the neutrinos that are released when you have, say, a neutron going to a proton, an electron, and an antineutrino. It's not those kind of neutrinos, because that kind of neutrino is relativistic, and basically you need something like 9 light years of lead to slow it down, a little bit. Whereas these neutrinos, as is extremely well argued in Alexander Parkhomov's book, these neutrinos are actually produced in huge abundance in the sun, but their speed is so slow that they don't have the escape velocity to escape the sun's gravitational well. And so we don't get these things generally from the sun. We get 50, I think it's 50 trillion per centimeter squared, like the size of my thumbnail there, from the sun, but they're all relativistic neutrinos, and they have very low interaction. But the cold neutrinos that are synthesized, they can have a much higher interaction, because their de Broglie wavelength is in the microns to millimeters. And in fact, some people are saying these things can be a meter. And I will talk about that in other presentations and how that leads to issues with consciousness and stuff. But anyway, So anyway, these things are produced in the hot dense matter, and this leads to the production of these magnetic charges, which he refers to several times in his presentation. And ultimately, the magnetic charges leads to unification of the forces, and this allows both very, very easy transmutation as well as nucleon decay. And so it's quite well argued in the patent there, and it's been observed by other people. So and the patent's free to use now. You can go ahead and make this. Now the interesting thing is that this is using a industrial electron beam furnace. It's a very large device, very expensive, and it's not something you can go and buy at your hardware store. However, we produced exactly the same observations with the Lion series families of reactors for, maybe the time for people to do it is several $1,000s, but the actual equipment to do it is probably a few hundred to maybe $500. So for those people that want to replicate this and observe the same phenomena, it's really quite cheap. Okay, we have something. Right. Okay, so that's the Solin patent there. Now, so he's claiming magnetic monopoles and quantum coherence, and then there's the magnetic monopole production and capture by Arutskiev, and I explain it in this presentation here, but essentially this was from 2002. And he exploded some wires, and he created ball lightning outside of the reactor sometimes, which you can see here, which is quite amusing. These ball lightning. So the actual reactor is below here, and the ball lightning appeared outside of the reactor. So this is something, and he talks about how this can't be something that was conducted up through the wires or whatever. So these are balls of fire that somehow came from the inside of the reactor and came to the outside of the reactor. So this is another presentation where your study where you're seeing that the thing can transfer through materials. And you can also see here in this one where you have the main ball of fire, but it's starting to disrupt and it's throwing these little bits of balls of fire out from its core. Okay, so anyway, what he discusses in here is that he exploded these wires, and I think it was 0.7 of a meter away. He had at 90 degrees to each other. So if the reactor is here, over here he had 0.7 meter away, and up here he had 0.7 meters away, but in the horizontal plan view. He had some pure iron 57 foil, and then behind that he took a reasonably okay magnet, doesn't need to be super strong, not necessarily strong as this, and put it on the back side. And one he had a north on, and the other one he had a south on. And of course, iron 57 has its own nuclear magnetic resonance, and it produces its particular signal in an NMR machine. And he took the control sample that didn't have a magnet on it; it was in another room. And then he took the other two samples, and he found that on one it changed it up, and the other one it changed it down. So he proved in 2002 that these things that were flying out of these exploding wires had a monopole-like nature and could change, and they were binding, by the way, to the nucleus of the iron atom. So that's very important for where I'm going to go for next. Now, in the magnetic monopoles in water, in 2006, Filipov and Uritskev discussed that the stopped turbine generator at Chernobyl, it discharged, and if you look at the discharged, I did a calculation. I would have been nice to present it here, but it is, I think it's of millions or I don't know. It's a very, very large number of orders of magnitude more energy than was being used by Aroitskev in his studies in the old isotopic unit outside of Kiev in the Ukraine. Anyway, so and he argued that this produces vast numbers of this so-called strange radiation, these quanta of exotic vacuum objects, and that this went into the water and became bound to the oxygen in the water, and that then this traveled through and created like a magnetic current. and the magnetic current, they observed, blew things off the wall, and then he goes through the transmutations that occurred and the fact that they found elements inside the pure carbon moderator blocks and so forth. But he argues that very well, and I agree with his assessment, I think, but I'm not necessarily agreeing with that. I wrote another piece, and if you actually look in Tom Bearden's, he refers to the Duga array, which is 4 kilometers away from Reactor 4 that blew up, and the fact that they were weaponizing that, and that is relevant to what we're talking about today, because they can use the scalar energy from those arrays to charge the magnetite in the subduction zones or in volcanoes and cause premature eruptions or earthquakes. And he says in Tom Bearden's book that what they did is they saw this radiation coming in, they were sensing the earthquakes being caused by it, the loss of life could be in the millions, the tens of billions or whatever it was of economic damages. And so the military came to him and said, look, we have a potential solution. We don't know where the radiation is coming from, because at those times they didn't have the satellites. And they had a phase conjugate array where they could effectively reflect the energy back, and that went into the Duga array. They discharged it into the ground. It travels about the speed of electrons in a wire, not the current, which travels at near the speed of light, but the electrons travel at 2 to 3 centimeters per second or whatever, and the distance between them, and that they then got to the reactor and discharged it. But the difference between those two arguments, now he doesn't call them exotic vacuum objects, he didn't really know what they were at that time, but the two different explanations are both referring to exotic vacuum objects being the cause of the explosion, not the wonderful, absolutely brilliant drama you see by HBO, which is wonderful, wonderful television, but just not honest. Anyway, okay, so in this one I talk about the monopoles in the water there. Now, in 2012, a guy called Perovchikov and his colleagues, they found that if they got a 0.4 Tesla magnetic field, like not too dissimilar than you would get from this, had a whole bunch of these, and then put a Petri dish or whatever above and put some water in and stuck it out in sunlight for a week or 2 weeks, that if they then fired a laser into it, they would get these typical kind of quanta. This is the mushroom, the birdie, as Shishkin and Bogdanovich call it. This is the kind of one that they observed on standard sort of 32 millimeter black and white film. So this is actually a really affordable experiment to observe the various quanta of strange radiation. So you get rings, you get chains, and then as the quanta goes up, you end up with these birdies. And these are the ones that, in my view, really do the business. And in fact, in my view, this is essentially the Boyd-Bushman magnetic beam, and it's essentially what enables a lot of these exotic technologies. You know, I actually don't know whether people that are trying to reverse engineer these technologies actually know what they are. I don't know, but you know, it's weird. There's so much pride going on, and maybe they're so compartmentalized they've never read this work and they couldn't consider it in the same framework. But anyway, they're going to find out sooner or later. Okay, so this is in water. So what we've got here is we've got two examples of it in water. We've got it being caught by ferromagnetic material. We've got it forming in paramagnetic material, and we've got it in paramagnetic water, of course, and so forth. So there are various ways you can capture this. And then I talk in this last one here how in 2019, and this is in the Russian, this is Bogdanovich et al. At the Russian National Nuclear University in Moscow, and he fired a linear acceleration of beams. So it's a bit similar to the Solin patent here, where you've got the beam of electrons coming down here, but they're doing it in a LINAC, a linear accelerator. So they're taking it to a higher energy. And so if I actually go to the point in this, maybe I can find it in this presentation. So here's their birdies. So they're very, very similar to the ones observed by Perovchikov. And if we go on, these are ones observed by Shishkin et al. And this is at the Science City in Dubna. It's north of Moscow. So these are the kind of birdies that they've observed. And actually Shishkin's quite good because he credits the potential original discovery of this by Barkla, who discovered characteristic X-rays. And Barkla saw these things and he called them J radiation in, I think it was 1909 or certainly in the 1910s. And after he got his Nobel Prize for characteristic X-rays, he actually spent the rest of his life trying to work out what this J radiation was, because he called it J because it was more energetic than you could possibly get from any K-shell emission. So there we go. Anyway, so I've got it here. So what they're doing here, oh God, if I can get to it, there, okay. So they've got a synchrotron here. Maybe I can get them registered. Synchrotron here. Then they're firing the beam of electron through conversion targets. Then they have a magnetic thing here to separate the electrons and just have gamma rays. And the gamma rays go through to an X-ray plate. And that is where they observed these birdies here. So they observed exactly the same thing that Professor observed, that was observed by... in my view, it's in the Hutchison samples. We've got several Hutchison samples with these things that have actually eaten material out. And sometimes you see a hole in the center here, in the center of the head of the bird, and sometimes you see a sphere of material. Now, is that a north and a south? And a north is throwing the material out through this channel, and is the south packing it in there? You know, certainly other things that we've observed online would suggest the same thing. Here's an explanation that goes back to, it starts off with Cooper pairs, and Cooper pairs are a boson, so you can make that. In fact, I'll try and get this at a higher resolution, then you can probably see it. That would be useful. In this case, they're spiraling down and they become coherent. They go down to their magnetic core, and this causes a spiral. So this is one explanation that was given, I think, in Russia in 2008, I think, at a conference. So you get the spiraling in, and so you end up with this overall structure. So you get the helicopter head. Sorry, you can't see where my mouse is. This again. You get the helicopter head, and this is the spiraling in. This is it's a derivation of Dirac's so-called monopole, but it's not a real monopole. It's like a virtual monopole. Anyway, so what I'm arguing actually here is that what you could do to realize this casting technology is you could actually apply a number of different technologies. So if I go back to the one that I discussed earlier, you could take several different approaches depending on the tools you had. So if we're looking at this andesite here, and by the way, magnetite also has that in it, and I will show. Don't let me forget, but there's something I need to show you about. Basalt rather. Basalt has magnetite in it as well, and I need to show you something at the end because it's very, very relevant. Anyway, so I've talked about doing it in situ. So you've got your rock, you've maybe chopped out a big rock, and you then move the rock, and then you put it in top of your mold, and then you fire in your neutral exotic vacuum objects, which are neutral electrically, so they can go into the rock, but when they interact with the magnetite is magnetic. It's a little magnetic island, and it binds onto there, and you get an aggregation, and so you can imagine a whole bunch of exotic vacuum objects coalescing around these various pieces of magnetite, and then you use some sort of scalar wave, or maybe even just sound. You might be able to energize these things just with certain frequencies of sound. And then the material would become plastic, and you could push it into your mold. Maybe you could just push it down with your hands, or you could get if you had like a wooden mold to get nice, very fine, sharp edges. You could then just put another big piece of wood on top and get a few guys to stand on it, and then wait for it to discharge itself. So yeah, if you actually look at the 2D images like a bird shape, yeah, I've actually done 3D images of one proposal of the kind of shape of it. So you can go and have a look at those in those videos. So this is one approach. Now, the other approach is where you overcharge these things, you blow the thing up into dust particles, as it says in the Salvatore Pais, a high frequency gravitational wave patent. And they say, yes, if we use like 4 devices the size of a domestic fridge and we put them around the planet and we use the power that it takes to run a domestic kettle for about a week, we can turn the entire planet to dust. Well, when you understand this technology, then you can realize how they can say that. And they say, oh, by the way, we can also do this to incoming asteroids. Yeah, great, thanks. Why do you even have to mention about the turning the Earth to dust? But anyway, the point is that this is unimaginable power, and people need to be aware that these things are being put onto weapons. Okay, so you could put your stuff into dust, you could carry it in bags, and then you could mix other stuff in there if you wanted to give it a different property, but and then make your particular type of geo-polymer, as it were. And so if I go back to here, now why am I talking? Firstly, we know we can create these things cold because we know John Hutchison's done it. What John Hutchison did was show what was possible. Doesn't matter that he just didn't know which knob to twiddle, and you're not going to just necessarily discover it because he had this old military equipment and he was able to use frequencies you're never allowed to buy, or even if you make it, you're not allowed to use anyway. So maybe it was one of those frequencies that was able to create the coherent matter. But the really interesting thing here is that in this last presentation I have down here, talking about the Bogdanovich work, he says, in case of the synchrotron experiment, it can be assumed that the monopoles were originally located on the magnet surface facing the medium plane where the electron beam moves. The halo effect of the electron beam and a significant part of the Bremsstrahlung photons fall on these surfaces and can initiate the output of monopoles due to the photoelectric effect and secondary emission, especially since the output is facilitated by the magnetic field of the magnet. Okay, so this is similar to what's happening here. You're charging up the water and then you fire the beam in the laser beam, this itty bitty little laser here, into the water that's been charged, and out comes these little birdies. Okay, so here's an idea for you. If you have a magnetic thing like this magnet that I'm holding in my hand here, or this magnet here, what Bogdanovich is saying is that this magnet is collecting monopole charges all of the time on its surface, all of the time. And the implications of the Perovskite work is that the water, because the water is, the oxygen is paramagnetic, that the quanta that is in the natural environment, as talked about by, what's his name? Alexander Parkhomov, and also there's a guy who did like a study from the 1950s, and I'll remember his name in a minute. But anyway, that guy, he showed that there's this common cosmophysical factor. If you go and look at the Shishkin presentation from Sochi that I translated and gave a presentation on, you will see that mentioned in there. It's called Schnoll, Simon Schnoll. So if you go and look at Simon Schnoll's work, he says there's this common cosmophysical factor. Well, anyway, this is coming from the cosmos, but it's binding to the magnets. And so you have water and magnets, and it is the gamma rays that's extracting it from the nucleus of the magnetic material. And it says it's basically, in this pattern, it says this is a fundamental property of physical material. It's always there. If you go back to the so-called NASA work that's come out, the SPAR-Wire work, what are they doing? They're taking, I think it is the second most magnetic susceptibility nuclei. I think it's that. I actually mention it in my, in fact I can go and get that. It's in my Russian paper here. I think I go, where is it here? Okay, so yeah, so I go here. They are using erbium, and erbium. You can look at how paramagnetic is. So if you go and look here, this paramagnetic, its magnetic volume susceptibility is 0.034. Basically, I think it's the second most highest magnetic susceptibility. But of course, it's a nice. Anyway, that's my point. It's highly paramagnetic by volume. So it can collect these things, and when you fire the gamma rays in that they are producing, they're having a whole reason for it doing it. But I think what it's producing is it's releasing these magnetic monopoles. They are clustering, and they are enabling the fusion or fission processes that are going on in that material. So I actually fundamentally disagree, and I don't believe that if they'd used bubble detectors, which are not susceptible to electromagnetic radiation other than thermal, that scintillators are. And if they had used indium or gold activation and then subsequent monitoring with Geiger Muller tubes, I would have believed their data. But I can't take it seriously. And it's getting a lot of press. And I don't know quite how to deal with it. But anyway, that's that. So what I'm saying is, you could crush up your non-ideal magnetite, sorry, your non-ideal andesite or your non-ideal basalt, if you wanted to do these geomopolymers, and lay them out in the sun. Now you already have the magnets in there, these little magnetic bubbles, right? And the sun's coming down, but it's not the sun. The sun might help, you've got photons involved. But you have this flux of these cold neutrinos coming in from the cosmos all the time. And the magnets could then, the little magnetic domains in the crushed rock could then sort of accumulate this, just as the water is doing in this porosity curve experiment, and just as the Arutskiev Iron 57 was doing. And they become effectively charged with these monopoles. Now, these monopoles, they have a weird kind of fall off. They're not linear. They have a very kind of defined boundary. So they have a very small influence, but it's very intense in that influence. And so then you have material that you could then put in your mold, and it might just bind and produce your geopolymers with a much, much less effort after you've charged them up. And so there we go. And that's essentially most of what I wanted to say today. So I'm going to see if you have any questions. Okay. Okay. Voltage goes across the speed of light. Has anyone you know replicated that yet? All you need is sunlight and magnets. No, I believe there's other ways to replicate it, which I will talk about. I'm going to put together a site, and it's going to have a special name. It's in the works, but there's a whole series of relatively easy experiments to do. This is one of them, and we need to respect the quanta of strange radiation that is in the monopole state, and in fact some of the other quanta as well, because it has proven biological effects, and it can, several people have died of cancer. So, yeah. They don't want to share the information that there is certainly, I've got that impression sometimes. This is so bizarre. What is so bizarre? Massively interacting magnetic particles. Yeah, maybe. I mean, the actual, as Parkhomov calls it, he calls them like, they could be WIMPs, these weakly interactive massive particles. Sunsaver, if you had a coherent matter
covering a wire, it would just be like, so I was thinking about this today when I was going to the supermarket. You could actually make a lightsaber, and it would be like one of those telescopic aerials that you had on an old radio. You just pull it up like that, but actually just does it mechanically or inside. It goes up, and what it does is it puts a coherent matter coating around the outside of the thing, and then you could literally slice through anything. Anything. The only thing it wouldn't slice through is another one of these devices, which is exactly what you see in a lightsaber. I always thought lightsabers, they're so stupid because you get the light goes out to a distance and then it stops. How would you do that? But you could just do it like this. It's literally a retractable telescopic piece of metal, or it could be a piece of andesite that's telescopic. Anyway, and you put the coherent matter on the outside, and you would literally be able to chop through anything except another lightsaber. Do you know if anyone is selling that type of water? The water is just water. They didn't use any special water. Just water. Have you got any comments on the work patents of Salvatore Pay? The patents that I saw from there, I'm glad that they released what is possible with this technology. I'm not so convinced that their way of doing it is not a Gene Roddenberry or whatever it is. The phrase that means that it's like overly complicated. It might be that with something that is based or could be derived from what they've written in those patents, that they have some working embodiments, but they look a little bit overly complicated to me. The technology isn't that complicated. There are some nuances which could take millions of lifetimes, but I doubt it. I think if people start being serious about this, you look what's happened with the Vega experiments. We've gone from just doing something different and applying what we've known before. We have observed things that are really quite shocking and very clear to see what's going on, and they're relatively easy to replicate. So it's about doing, and it's John showed what was possible. Okay, when you know it's possible, then it's like, how do we make a technological device out of this? Okay. Yes, the Russians all believe that Yuji Bashetov, who ran the cold nuclear transmutation and ball lightning conferences for 25 years, he died from exposure to strange radiation. And I believe that Norris Peary died from exposure to strange radiation created in his microwave reactor. And I believe that Ken Shoulders died. And also, the reason I haven't run my the supernova reactor, is because I really wanted to understand the radiation that it emits and how to best protect from it. I think I have a reasonably good understanding of that. Of course, dilution is a solution to pollution. And so you might need to have a greater distance from it. Anyway, the fact that the guy that built that died at the age of 40, and he was exposed to a number of these supernova and nova reactors, I don't want to be another person that dies because of exposure to strange radiation. And we know that it's producing strange radiation. Okay. Does the beamer accumulate and fire these monopoles? The beamer. The Tesla death ray was creating electronic particles of matter, and it's essentially a dielectric barrier discharge in water through dry steam, and so it's basically creating exotic vacuum object beam. Does that? Oh, so Oh, I see what you're saying. You mean the beamer from Lockheed Martin? Yeah, I believe it does. It doesn't necessarily need to make monopoles. It can just make the whole coherent matter. It's just a beam of coherent matter. It starts being produced and it's continuously, it's the same beam. I mean, you could pulse it. I thought you had shared a hand-drawn picture that you said came to you in the dream. Yes, I have. And in fact, there's another hand-drawn picture that came to me within 24 hours, which I will share to you as I explain more of this that I haven't disclosed. If you want to see that, it's in my presentation from Russia, so not this one. So let me find that, and I will show you in a minute. Now, there's something that someone shared earlier today, which I just thought was absolutely beautiful, because it does not surprise me, because when you know what's going on, it is what it is. It's always going to show these things. And so what it was a company that has used, where is it? Let me see if I can find it here. Aha, yes. Now, I'm going to go up here, and is that going to help me here at all? No, that's not going to help. Why didn't that work? Now, I believe I've shown, and there's much more data which is just going to be absolutely mind-blowing, that Amasa gas, which is a type of oxyhydrogen gas, is able to transmute elements. So if you look at snowballs on cobblestones, a video on the Martin Fleischmann Memorial Project's channel, you will see that I found that the Amasa gas had taken oxygen from the surface of copper, and it had fused the two oxygen-16 into sulfur-32. And this is classic ball lightning type transmutation. So we have a correlation between what ball lightning naturally does and what you observe as these microplasmoids, as some people call them, but they're micro ball lightning. It's moving around the surface, and you can see it's eating material and getting bigger. The snowball, it's literally like rolling a snowball. It gets bigger and bigger. And so we know, and I call this, since I witnessed the data actually happening, that we are making strange radiation in the Amasa vibrator system, and that it is producing this gas, which when burnt produces these microball lightnings, exotic vacuum objects, and that these are then able to interact with metal in the ways that exotic vacuum objects does. Well, it's very interesting, because this company is called Basalt Fibers, and they use their own HHO generator. They call it stoichiometric oxyhydrogen, just to try and make their own name for it. And they specifically create from basalt these basalt fibers, and they're a building material. Anyway, the point being is that we've gone from a situation of a couple of days ago talking about how exotic vacuum objects can produce geopolymers, to actually people starting with basalt and melting it with something that I have shown through the work that we did in Japan in 2019, produces Lena, and that is produced by exotic vacuum objects, and which I have said is like microball lightning, which has a coherent matter structure to it. And as I've argued here, it can be paramagnetically or magnetically aggregated, and is actually always on ferromagnetic, paramagnetic, and so forth materials, and this is it. And so you actually have a company that is, without realizing it necessarily, actually using this technology. So I'll put that in. So this was, someone sent this to me a few hours ago. So I'm pretty certain, without a doubt, that this technology is what does these geopolymers. And if it isn't, well, we can do it. And there's a company that, guess what? They're doing it. They're doing it. So, and But there, and if you take the work of Yul Brown, and we have this Brown gas generator, BN 2000, that we intended to test to verify against the Amasa gas and see the different properties last year, but of course COVID got in the way. But it's low energy nuclear reactions in a can, and if you have the it's actually putting the material on, and I've described this in the presentation that I gave here in my I've got rid of that in my Russian presentation. Maybe I can open that last one up. File history. So in this Russian presentation here, I discussed how Yul Brown's technology worked. There's a Mars gas. I actually have a first time ever undisclosed picture of Yul Brown actually using his thing. So you can go and have a look at this in your own time. But I'm saying is he actually remediated nuclear waste by taking pieces of mild steel, which is ferromagnetic, and putting that with aluminium, which is paramagnetic, and it has a single isotope, so it's quite easy to get it into coherent matter state relatively to multiple isotopes. And then he hits it with he has in there the, whatever it is, americium 241 or whatever it is, cobalt 60, and he hits it, and what's happening is that the ion is getting hot. But it's got a Curie point of 769 degrees C, and as we showed in Japan, the temperature of the flame is actually quite low, and so the burning is producing a lot of exotic vacuum objects. They are aggregating on the ferromagnetic ion, and then what happens is he describes that he puts the flame on, puts the flame on, and then suddenly there's a flash. And I believe that what's happening there is the ion is going through its Curie point, and all of the exotic vacuum objects that have aggregated on the surface are coming off, and they are then self-organizing into a large coherent matter, basically like a ball lightning. And the ball lightning has a coherent matter sheath that is interacting with all the elements, and any element that is unstable will become stable. It doesn't want to be stable. Nature wants to make it stable. It knows it's going to go to stability because that's what radioactive decay is. This just accelerates time for it. It basically goes from 0 to hero and becomes stable. And typically what you get out, and he said, Yul Brown in one of his patents, that what you typically get out is carbon. And this is what you typically get out of these type of systems. Oh, the magnetic beamer. Yeah, so it's just firing out magnetic beam. But what's in the beam? What's in the beam? Yeah. Yeah, so actually, now I'm here, I can go to show the... oh, no, it's not in there. Anyway. The hand-drawn picture is in my Sochi presentation from 2018, so you can go and see it there. Okay. Yeah, I mean, the best shield for EVOs is a shield that's covered in EVOs. Like I say, the two lightsabers will cut through anything, but they won't cut through themselves. Keshi, well, I did a presentation. You can go and look at it. It's called Superconductivitis. It talks about Keshi. These structures infect materials. I talked about this in my last presentation. So if I created a load of EVOs in this Hutchison sample here, over a period of time, they would infect the whole thing. And because they are superconducting themselves, if they're big enough to bridge each other, then you have one coherent... damn, there's another dent in my laptop. You have this is aluminium, and it is so much harder than the anodized aluminium on the laptop here. It literally has a line dent. Anyway, the coherent matter goes all the way through it, so the whole thing becomes a superconductor. So I think that's kind of what he's doing. Yeah, about the Amasa videos, you are going to see something just absolutely slam dunk. Beautiful, beautiful, but slam dunk proof that this is transmuting. I mean, the snowballs on cobblestones does that, and it correlates to microball lightning and natural ball lightning. But you know, there's always people that will come up with excuses. But the data that will come is just breathtaking. It's just breathtaking. What they found is that aluminium is one of the best shields, but you need multiple layers. What you see in the Perovskitev work and in other work, in also the work of Matsumoto, if I go down here, is what they found was in the film, it would go through several layers and it wouldn't expose the film, but then for whatever reason it got excited and then split, and then the ends are highly magnetic of the bead chains, and they attach themselves to the film, and then they go along the length of the film. And so what you need is many, many thin layers, and ideally thin layers that I would suggest they are at a negative voltage. So if you go and look at the presentation I did where I was analysing the 1970s and 80s work of plasmatrons that was presented by Anatoly Klimov, you will see in there how if they get a charged mesh, you can see what look like the strange radiation or the matter coming out in this beam, and they have a Mach 2 jet that's coming across, and it's basically not deflecting it, but it hits this mesh that's negatively charged and it immediately stops. Now there is an issue with that. If you feed it electrons, these things can blow up, and then they can put subparticles out in a different angle depending on their quantization level and so on. But I will talk about shielding a little further down the lines. This is a very big subject. We used 5 times N42 1-inch diameter cylinder magnets, all pulse facing inwards, looked exactly like the pattern, but we couldn't stretch the spark of a Van de Graaff generator as Boyd described in his patent. I haven't tested it, but my guide for whether it works or not is to just go and look at the work of DuPont, the primer fields. You can see it in action really there. You might, Ron, you might have emailed it to me. It's true, you might. I get a lot of emails. Sorry, I missed it. Okay, Felix, that's interesting but not surprising. So when Dr. Roshin Amasa was discussing about whether he was willing to have a generator shipped abroad, he says you've got to be careful, Bob, because there's a hidden group and they don't want anyone knowing about atomic hydrogen. That's what he said. What I can say is it's past my bedtime, or past my curfew time, so I probably should go. I'll just try and answer your questions quick, and then I need to be getting on. Carbons is the end point for many things, and I would describe how that's important in another respect. But essentially, we can go to a planet that has any elements. It just needs to be a body that's in the habitable zone. And using this technology, and it only needs to be this technology, we can create all of the elements for life. Yes, we can terraform, and it is this technology that will allow us to do it. I will talk through how Amasa gas is working, and it's creating and imbuing the thing with the ability to then later create coherent matter. But I'll talk about that another time. So about the carbon, basically, carbon is triple alpha. So if you're observing what's left as a solid residue, the alpha's already gone. Okay, so you can't have beryllium-8 because beryllium-8 immediately decays into 2 alpha particles, so that's gone as well. So the first alpha conjugate nuclei that you can synthesize is carbon. That's why you see a lot of carbon. It's that simple. And that's why you see diamond. That's why you see diamond in Celani's work on his wires. That's why you see diamond on Leclerc's work. That's why you see, and it is the diamonds on Celani's work that we observed at the beginning of 2013 that led me to suggest the use of industrial abrasives like nickel diamond abrasives, and that's what led the Lion researcher a number of years later to try and produce the Lion experiment. Or rather, I don't know whether he did that, but I put it out into the field, so it was made public, so it couldn't be patented. And it seems to be a very good way to do it. Okay, so oh God, I don't know whether there's so many. Okay, I can see Felix. Water is the fuel yet, Stanmeyer. Yeah, there's a couple of aspects as to why it changes fuel mile per gallon, and we can talk about that another time. And there's ways that people it can harness other energies, and I will talk about that also. I'm doing a series called "What Goes Up Must Come Down" on remote view .icu, and that will lead into some understanding that's necessary for that. Yes, unfortunately, the easiest thing idiots can do with this is make terrible weapons. The negative web side of this has already been done. It's like I say, it's stupid people can do the bad stuff first, and then they can go, oh look, I can do things that blow things up faster and easier, and it's like, oh, we'll buy that. And it's like, and we're all trying to find solutions to real problems rather than ones that just make problems. So, you know, like I say, the cat is coming out of the bag, and we need to ensure that we work as a community to ensure that the benefits of this technology is delivered rather than just the negatives. Mercury was used in transmutation in making gold. Mercury is a very heavy ion. It's already a liquid. Mercury was used as one of the electrodes in the Tesla 1932 pattern or drawings for his ray gun. It was used by Ken Shoulders, and in fact, in current fusion reactors, they're using it for the same reason, that it can self-heal. Because you want that. So you get like a little Taylor cone forming when you've got your capacitor plates, and as the discharge happens and your EVO forms, it's a nice heavy ion to stabilize the exotic vacuum object. So you and if there's some speculation that isotope 199 would be ideal for use in sort of anti-gravity craft as a building block for the exotic vacuum objects. Well, 199 is like right in the middle, and it's a fermion, so it kind of will resist certain aspects of what the technology does, and because it's right in the middle of the isotopes, then if it does some transmutation, if you've got hydrogen making the basic EVO, then it kind of transmutes to other isotopes of mercury, if you know what I mean. Or if it's a mercury-mercury exchange reaction, you end up with an energetic yield, but only to other isotopes, mostly of mercury. So it has many reasons why it's good. Felix, at the moment, I believe that I have a number of different things, and like I say, I came up with a generalized device using ball lightning and some for heat and for radioactive remediation of products, which would just be a continuous process, and you would have a hopper. You put this material in that you wanted to process and produce energy from, or remove the radioactivity from. And then there's other approaches for producing direct electricity, and so but these things are long journeys, and really my role, I believe, at the moment is just to get the information out there so people can see firstly that this is true, that it's real, it's deliverable, and that essentially all novel energy systems that have ever made their so-called inventors believe that they could deliver, they're all based on this technology. How did it? Bushman's dead. How did I not connect LaPont with? Oh yeah, I don't know. Take care, dude. Okay. Is helium 1-2? What do you mean? Helium's pretty useless, actually. It's like the nuclear graveyard. I mean, you can take the nucleus of helium because it's a boson if you fully ionize it, and then you can use that in the exotic vacuum object to merge with other nuclei to give you energetic yields. Oh, David, the stuff about the Imasa gas, the SEMs, the data. When you see these things, you go, I know there's something important there, but it takes you a bit of time to think about what is going on and the significance. But it's just breathtaking. It also helps to understand and be able to see in experiments exactly what's going on when these coherent matter structures, because of their magnetic nature, how they group around things and don't group around other things. Carbons, well, I said before that exotic vacuum objects, I said this in my Russian presentation, or it might have been the previous one that I gave, but anyway, they're both published. The exotic vacuum objects like to aggregate into all of the structures, the allotropes of carbon, whether that be nanotubes or buckyballs or so forth, and then clusters thereof. I haven't seen any spoons from spoon benders. I think Dr. George Eagley has one that was done by Uri Geller. He said that after it was given to him, in fact, no, Uri Geller did it and he put it down on the table, and then he picked it up and put it in his pocket, and he could feel it continue to bend in his pocket for a period of time after he actually nicked it. So I'm pretty certain that Dr. Eagley's got it. So hopefully, maybe when I next see him, I can ask him to let me see that spoon, maybe, and we can analyze it if he has it. I think Sapphire are doing a fantastic job, and they have, let's face it, they have Eric Davis on the team, they have George Hathaway on the team, they have Hal Puthoff, and all of these people were involved with the early days of Ken Shoulders trying to work out what John Hutchison had done. So they've really had a long time to think about this. So they've certainly got some good team members that I would expect them to. And I've tried to help them with issues with strange radiation and how to protect from that. And I'm willing. They reached out to me at the end of last year and said, look, would you consider doing this, and would you sign an NDA? And I said, no, I'm not going to sign an NDA, but I'm willing to discuss how you can protect yourself from this radiation. Okay, I'm going to have to go. So thank you very much for your time. I know time is precious for everyone, and so that's it. Essentially, I think really I've given you all of the keys to understanding, in my view, how geopolymers can be made, and also other techniques for moving these things and for cutting them and so forth, and a few nice tidbits like how to make a lightsaber and so on. But when you see, I mean, when we were using that, we had a 10 yen coin and we had the Amasa gas torch, and it didn't do anything. But because copper's diamagnetic, you end up building a big plasmoid on the top, and then it just gets to the strength, and then it just eats anything. And and if you look at the microscopy and photographs I've shared, I remarked at the time that it's literally like a perfect cut line. It's like copper's like super conductive, so you would imagine it would be kind of bent over because it was kind of all melting, but it didn't. It's just like a laser has cut through it. But the ball lightning has basically got to its extent, and it's eaten the material. That's my view. Okay, so I'm going to go. So thank you. Bye-bye now.